Okay, so for 1.4 day 2, we are still going to be working with a system of equations, except for today we're working with a system of equations with 3 variables. So rather than just working with x and y, we'll see equations with x, y, and z. So we're adding in a third plane, if you will. Normally we work with the x and y axis, right? So like if I draw the x and y axis, looks like this, right? Here's the x and y axis. We are going to be talking about a z-plane that comes through this way. So it's almost like a 3D model, creating that third dimension for us. Okay. So we're going to visualize solutions of systems of linear equations with 3 variables, solve systems of linear equations with 3 variables algebraically, and then talk about how to set up a real-life problem. How does this apply to the real world, right? So a linear equation in 3 variables, x, y, and z, is an equation of the form ax plus by plus bz equals d, where a, b, and c are not 0. They're not all 0. Okay, a solution of such a system is an ordered triple, x, y, z, whose coordinates make each equation true. So just like normally we write our answers as x, y, today we're going to write our answers as x, y, z. Says the graphs of 3 such equations that form a system are 3 planes whose intersection determines the number of solutions, as shown in the diagrams below. So when we're talking about systems of 3 variables, there's 3 cases that can happen. You can have all 3 planes that intersect in a single point, so there's only one solution. So you can see here they all intersect in one point, so there's one solution. You can also have a case of infinitely many solutions, where if the planes, intersect in a line, then every point on the line is a solution of the system. So here's a picture of 3 planes, the blue, green, and red plane, and see how the intersection is a line. In that case, you'd have infinitely many solutions. And then there's also a case where there's no solution. I think the best case is this one right here. It's the easiest one to visualize. If you have 3 planes that are all parallel to each other, so like the ceiling, the floor, and then maybe like the ceiling above on the next level. You picture that like a building. That would be a case where you have no solution. Today, our focus is just on this one right here, getting exactly one solution. Okay, so we're not going to focus on infinitely many or no solution today. We're just going to be working with systems that give you one solution. All right, so here's the steps. When we are doing 3 variable systems, the first thing I want you to do is I want you to choose a variable to eliminate. Right off the bat, looking at the 3 systems, you have to make a choice. You have to say, okay, I'm going to eliminate y. Okay. Once you make that choice, you're going to rewrite the system as a linear system in 2 variables. And to do that, we're going to have to use elimination twice in order to set up that third elimination process. We're going to have to solve the new linear system for both of the variables, substitute the values of the variables into the original equation, and then check our solution. Okay, so you're going to see what this process looks like. Example 1. Okay, so see how we have 3 variables? 3 variables, 3 equations. Okay, so I'm going to call this equation 1 my equation A. I'm going to call equation 2 my equation B. And I'm going to call equation 3 my equation C. So when you hear me say equation B, you'll know exactly which one I'm talking about. Okay? I need to take an equation with 3 variables down to an equation with 2 variables, down to an equation with 1 variable. That's the idea. So can I solve an equation that has 3 variables? No, the only types of equations we can solve are equations with 1 variable. Right? So I'm going to go from 3 to 2 to 1. That's the idea. And this is how I'm going to do it for the elimination method. The first thing I'm going to do is make a choice. Look at your x's, look at your y's, and look at your z's. What variable do you think is going to be the easiest to eliminate based on that? Yeah, I mean, X would be, really none of them are bad. X would be a good choice. Like if you're looking at A and B, you could get 4x and negative 4x. If you're looking at B and C, you could get 6x and negative 6x. So that's not too bad. If you look at Y's, if you look at A and B for the Y's, you could somehow get a 6y and a negative 6y, right? And B and C, you could get negative 3y and positive 3y. Okay, so nothing really looks bad. I'm going to just work with X's, okay? But you could have worked with Y's. You should get the same output at the end. Okay, but you'd make a choice. So I'm going to choose to eliminate X. Okay, so that's what I'm going to choose. I wonder what I chose here. On my note sheet, I chose to eliminate Y. Okay, to do it different. Okay, so let's choose to eliminate X. I'm going to start with equations A and B. How am I going to eliminate X? Well, A I'm going to keep exactly the same, and B I'm going to have to multiply by negative 2, right, in order to get a negative 4x. So all of B I'm going to multiply by negative 2. A will have 4x plus 2y plus 3z equals 12. And for B, if I multiply the first term by negative 2, I get negative 4x. If I multiply negative 3y by negative 2, I'm going to get positive 6y. And to multiply 5z by negative 2, I'm going to get negative 10z. And negative 7 times negative 2 would be a positive 14. Right? Every single term gets multiplied by negative 2. Did I do that right?
Yeah.
Okay. Check my work as I go, so I don't want to make a mistake somewhere and then have to redo everything. All right, here we go. So I'm going to add these two together. The x's drop out, which is exactly what I wanted to happen. This becomes 8y. And then this becomes negative 7z. And this becomes 26. Right? Can I solve a system with two variables? No, I somehow still need to do more work to get this down to one variable. Okay? So I'm going to put a pin in that, and I'm going to choose two other equations. I've already done A and B, so pick another set of two. Let's just go ahead and do B and C. Okay? I'm going to do the same thing. I'm eliminating the same variable. If you chose to eliminate x at the beginning, you are still eliminating x. Do not pick a different variable. Okay? So we're still working on eliminating x. What would I have to do to B and C in order for x to go away? Yeah, multiply b by negative 3, right? Because then we have a positive 6x and a negative 6x. So I'm going to multiply all of b by negative 3. 2x times negative 3 is negative 6x. Negative 3y times negative 3 would be positive 9y. 5z times negative 3 would be negative 15z equals, and then negative 7 times negative 3 would be a positive 21. Okay. C we're keeping the exact same. Okay. So when I add those together, the x's drop out, which is what I expected, right? We chose to eliminate x. This becomes 8y, 15, 14, 13, 12, 11, minus 11z equals 21 minus 3, 20, 19, 18, right? Okay, did I do that right? Did I add everything right? Okay, so now I'm going to call this, I'm going to give them new names. I'm going to call this my equation D and my equation E. So now I have two variable equations, right? We took 3 variables down to 2 variables, and now I'm going to take it down to 1 variable. So I'm looking at my equation D and E now. And I'm thinking to myself, what could I do to equation D or E, or both, to get one of my variables to go away? Which variable looks like it would be easier to eliminate, y or z? Probably y. I see an 8y and an 8y. It would be nice if I had one 8y and one negative 8y, right? Because then when I add them together, they drop off. So, Carly, what would you do to either d or e? Great. Let's keep d the same, and let's go ahead and multiply e by negative 1. Okay? I'm going to copy d, 8y minus 7z equals 26. And e, we're changing every sign. So we'll have negative 8y plus 11z equals negative 18. Okay. So now the y's are dropping out, right? 8y minus 8y is 0. Negative 7 plus 11. 8 minus 11, that would be 4z. Okay, positive. And then what's 26 minus 18? 18? 8? Which one is it? 8. I heard 2 different things. Okay? Divide both sides by 4. And we get z equals 2. See how we went from 3 to 2 to 1? And then we could solve it. Now, I know that z is 2. I know one thing. Where can I plug that information in to get more information about another variable? Can I plug z equals 2 in up here and get what y or x is? No. Well, if I plug in 2, then that would be plus 6, right? But I still have a 2-variable equation. Can you solve a 2-variable equation? No. You can only solve it if it's a 1-variable equation. Where could I plug in 2? D or E, right? If I plug in that z is 2 here in D, see how I only have 1 variable left, it's just y? Or see how if I plug in 2 over here into equation E, how I would have negative 11 times 2, and then I only have 1 variable left, which is y? So just make a choice. It doesn't matter. D or E. Either one. Okay. So I'm going to do, I'll do D. Okay. Let's see. Pam, read me what that would be if I plugged it in.
8y minus 7z equals 26.
7z, so I'll plug in 2. Yeah. You said equals 26?
Yeah.
Thank you. Okay, so we have 8y, and I'll label it that we plugged it into D. Minus 14 equals 26. Add 14 on both sides. What would that be? 10, 3, 4, 40?
Yeah, that's why
Divide both sides by 8, y equals 5. Woohoo! We got 2 of them now. And now that I know 2 variables, what they are, how can I find the third? Now where do I plug in the values for those 2 variables? Now I can plug those values back into A, B, or C, right? Because I know 2 of the 3 variables now. I just got to find one other variable. Doesn't matter where you plug it in. No. Question?
Can you still plug it into E too?
Let's see. What do I know? I know Z and Y, so I need X.
Oh.
So see how we already know Z and Y now?
Yeah.
So the only way to get, you're right, if I had X in either D or E, I could, but the problem is we chose to eliminate X out of both of those systems.
Mm-hmm.
So I almost have to plug it into the top one. Yeah, so, all right, so now I'm going to do X. And I'll go ahead, let's just plug it into A. So what do I got? I've got 4 times X plus 2 times Y, which Y is 5. Plus 3 times Z, and we said Z was 2, right? Okay, equals 12. So we have 4x plus, let's see, this is 10 plus 6, 16. 4x equals negative 4. If I subtract 16 on both sides, that's negative 1. There you go, there's your 3 variables. Now, do I want you to just leave it as 3 different boxes? No, I want X comma Y comma Z. So I have X comma y, comma z. So what's that? -1. What was y?
5.
Okay, that's what I wanted for our answer. So when I got this way, -1, 5, 2. Excellent. Okay. And like I said, your choice might be different than mine. Like on my note sheet, my original note sheet, I chose to eliminate y, which was different. Let me pull this out so it's not so glary. This is what I did at home before I presented it to you. I chose to eliminate y first. See how I canceled out the y's, and then I got down to two variables. And I brought the two variables together and then eliminated x's. And I started by getting z first. Then I plugged it in to d or e and got x. And then I took those two and plugged it into equation A and I got y. So see how the process is the same? Yeah, Ron?
Is 3 variables the most?
Yep, you can do more, but this is the most we're going to do. Yep, if you had 4 variables, you would need 4 equations. So we're going to stop with 3. 3D is enough for me. Okay, good question. Okay, but see how the process is the same? Your process might look different than mine depending on what that first variable is that you choose to eliminate. Okay, but you still should get to the same answer at the end. All right, let's try another one. Does anybody need that up there anymore? Do I need to scroll back to any one of those steps? Okay, remember this will all be on Canvas later as well, so you can reference it later. All right, so we're going to do another example. Again, it's solving a 3-variable system, and we're just going to find one solution. That's our focus today. We're not going to focus on many solutions or no solutions, just the one solution. Okay. All right, so looking at those 3 equations, which variable looks easiest to eliminate in your opinion? Okay, some people say x. Like if I let me title these really quick. Let me title this A, B, and C. So if I'm looking at A and B, it might be nice to have a 3x and a -3x. Right? If I look at B and C, again, it might be nice to have 3x and -3x. That would work. Look at the y's. -2y and 2y. Okay, that's pretty nice. Right? 2y and 2y. One just needs to be negative. Do you like that one better? 2x? I think that y looks easier maybe than x. Yeah, Ron?
You do A and B, can you just cross out 2y and z?
Yeah. So maybe let's try that, because right now if we just add A and B together, not only am I going to get rid of one variable, but I'm actually going to get rid of 2, which is nice. Because you're right, the z, the positive z and negative z will cancel. So, yeah.
If you did A and C, could you just eliminate X like right off that?
You could do that too. Yeah, so you're just basically doing 2 sets. So like pick 2 equations, add them together. Pick a different 2 equations, add them together. For that first step. Okay, so I'm going to go ahead and go with y, just because that's what I gravitated towards. If you want to try something different, you can. You should end up with the same answer though. Okay? So let's go ahead. I'm going to make the choice to eliminate y, but you can see how much flexibility there are in these problems. Okay, there's not just one right way to do it. There's lots of flexibility. Okay, so I'm going to start with A and B, because really that's going to be nice, because as soon as I add them together, the -2y and positive 2y is going to cancel. Okay, so I'm going to have x minus 2y plus b, bless you, equals -11, and then 3x plus 2y minus z equals 7. Once I add them together, x plus 3x is 4x. Those go away. And then z minus z, those go away. And that would be -4, 7, 8, 9, 10, 11, right? So here I just instantly take it down to one variable. That's nice. Because now I can solve for x. What's x going to be? -1. Good. Okay. Now, is there somewhere I can plug in x right now to find another answer? Not really, right? Because if I plug it into A, B, or C, I still have 2 variables. Okay, so I'm still going to have to do some kind of other set of another elimination process. This time, looking at these, I might choose A and C to put together. Because if I choose A and C, see how I have a negative 2y and a positive 2y? That looks nice, right? Because I'm still trying to eliminate y. I'm keeping the same variable that I'm going to eliminate. So let's do A and C now. I will have x minus 2y plus z equals negative 11, and negative x plus 2y, what is it, plus 4z equals negative 9. Okay, that looks good. Is it x minus x? Hey, that's nice too. That goes away. That looks good. 5z equals negative, yeah, I think that is negative 20. So z is negative 4. Okay, so we got 2 of them, right? How am I going to get the third one? I got x and z, I need y. Okay, so we can plug these in now to one of the original equations, right? Because now that I have 2 of the 3 variables, if I plug in x and I plug in z, then I only have a 1 variable equation. Y is the one that's left. Okay. Which one are we going to plug it into? Chase, pick one for me. Or am I plugging it in, A, B, or C? A? Sure. So let's plug it into A. We've got negative 1 minus 2y, which I don't know why, plus z, and z is negative 4 equals negative 11. Okay, let's combine some like terms here. We've got negative 2y, this is going to be minus 5. Right, negative 1 minus 4 is minus 5. You with me? Add 5 to both sides. What is that? What is negative 11 plus 5? Yep, 10, 9, 8, 7, 6. Yep. That would be negative 6. Right? We're in the whole 11, and we're only adding on 5 steps, so technically we're still in the whole. Okay, and then if I divide both sides by negative 2, get that y is 3. Okay, so do we get all 3 of them? Sure did. All right. Someone tell me, let's see, who haven't I talked to yet? Tyler, tell me how I write that as an ordered pair for my solution.
Negative 1, 3.
Excellent. Any questions about that? Yeah, that's it. I added, oh yes, from the last step. Yeah, I combined the negative 1 and the negative 4 to get the negative 5. Yep. Yep, if I give a friend $1 and then I give a friend 4 more dollars, we got $5. Yep, I'm down $5. Okay. Now, I didn't do this in the last problem. I skipped this step. But it's an important step. What step did I miss in the last problem? Check your work, right? I know what x, y, and z is now. How do I check my work to make sure that that's an appropriate solution? Plug it into just one of the equations. All 3, right? I plug in negative 1, 3, negative 4 in all 3 of these. So I'm going to do that on the board, actually. What did I say the solution was?
Negative 1, 3, negative 4.
Thank you, sir. All right, so if I plug it into the first one, we would get negative 1 minus 2y, which y is 3, plus z, and z is negative 4. And I'm asking myself, does that equal negative 11? Negative 1 minus 6, that's negative 7, minus 4. Yeah, that's negative 11. Okay. Plug it in the second one. 3 times negative 1 plus 2 times 3 minus a minus 4. Is that 7? Negative 3 plus 6. That's 3, right? Plus 4. 7. Da-ding. Okay. Minus a minus 1 plus 2 times 3 plus 4 times a negative 4 equals negative 9. Is that true? That'd be 1 plus 6, 7, minus 16. What is that? What is 7 minus 16? Negative 9. Boom. See? Turn in my quiz. I already know I got it right. Hey. Heyo. All right. Any questions about that? So that's the process I want you to go through. I want you to eliminate and eliminate to get it down to two variable equations. Eliminate a third time, and then you are solving that one equation. So it's like eliminate, eliminate, eliminate. You get your first answer. Then you plug it in. Then you plug it in. Unless something like this happens where you eliminate and eliminate, and you've got two solutions already, then you can just plug it directly into one of the first three. Okay. What about example 3? Solving a 3-variable system using the substitution method. Why did I pick substitution method here instead of elimination method? I already know what y is, right? That's cool. Let's call this equation A, equation B, and equation C. If you see something like this, how would you start it? I already know y is 2. Yeah, B is a 2-variable equation, right? If I already know that y is 2, I'm just going to start with B, and I'm going to plug in y. Right, y is 2. Plug it in. 3x plus, I'm plugging in 2, equals 5. Alright, now I have a 1-variable equation to solve. 3x equals, subtract 2 on both sides, 3. So x is 1. Alright, I've already got 2. I've got y is 2. I've got x is 1. Now what? Now you plug A and x is 1 into C, right? I know y is 2. I know x is 1. Now let's plug into C. Okay, so I'll have x, instead of x I'll write 1, minus 8y, and y is 2, plus 3z equals 9. That'd be 1 minus 16. Negative 15. Okay, plus 3z equals 9. Add 15 to both sides. What is 9 plus 15? 24, very good. Divide both sides by 3. 8, right? 8, right? Okay. Alright, x comma y comma z. 1 comma 2 comma 8. 1 comma 2 comma 8. And what's that last step that I'm missing? Check my work. Right? If I am taking a quiz or a test, you might as well check and see if you got the answer right. Because if you didn't get it right, then go back and try to catch your mistake. 1, 2, 8. Right? My solution was 1, 2, 8. Okay. X, Y, Z. Okay, the first one's y equals 2. Y is 2. 2 equals 2. Yep, that one looks right. Okay? 3x plus y equals 5. 3x, x is 1, plus y is 2, equals 5. 3 plus 2 is 5. Yep, that works. Okay. And this one is 1 minus 8y, which y is 2, plus 3z, z is 8, equals 9. Is that true? 1 minus 16, negative 15, plus 24. What is negative 15 plus 24? The 9? Okay. So we got it right. Any questions about that? On the last one, I want to set up a system of equation based on this word problem here. Okay, so I want us to read this together. It says, an amphitheater charges $75 for each seat in section A, $55 for each seat in section B, and $30 for each lawn seat. There are 3 times as many seats in section B as in section A. The revenue from selling all 23,000 seats is $870,000. How many seats are in each section of the amphitheater? So I need to set up 3 different equations. Let's say that A is the number of seats in A. Let's say that B is the number of seats in B. I think this grows. Copy. So we'll make B the number of seats in B, and L the number of lawn seats. Number of seats in B, and we'll make L the number of lawn seats. Okay. So now that I know what each variable represents, let's come up with an equation for each sentence. If I'm solving a system of 3 variables, we need 3 equations. So let's read this first sentence. An amphitheater charges $75 for a seat in A, $55 for a seat in B, and $30 for a lawn seat. $55 for a seat in A, $55 for a seat in B, and $30 for a lawn seat. And how much revenue do I make total from selling all the seats? $870,000. So follow this with me. I'm getting $75 per seat in section A. Okay? Plus, I'm also getting what? $55 for each seat in section B. Right? And I'm getting $30 from each lawn seat. And in total, if I add up all of the revenue, how much revenue am I getting from selling the seats? $870,000. Right? That's equation 1. Okay, we'll call that equation number 1. Okay? Equation number 2 says there are 3 times as many seats in section B as in section A. So there are 3 times as many seats in section B as there are in section A. Yeah, section A is right here by the stage. In section B, there's more of section B. So if I'm talking about equation number 2, how would I write that equation to say that in section B there's 3 times more seats than in section A? What would I have to multiply 3 by? Would I have to multiply 3 by A to get as many seats as are in B? Or would I have to multiply B by 3 in order to get a smaller number of seats in A? Yeah, you gotta take the small number of seats and multiply by 3 in order to get the bigger amount of seats. Right? I gotta take whatever section A is and multiply by 3, right? And that'll give me how many seats there are in B. Right? If I take 3 times the small section, will that give me a bigger number? Right? I multiply 3 by the smaller number, and that will give me the bigger number. Okay, there are 3 times as many seats in B as in A. So if I take A, the small number, multiply by 3, I get B. Okay? And the last guy says the revenue from selling all 23,000 seats is $870,000. I'm just going to focus on 23,000 seats. Everyone agrees. The variable A represents the number of seats in section A. The variable B represents the number of seats in section B. And L represents the number of lawn seats. How do I write an equation for 23,000 seats? How do I write an equation for number of seats? I've got a revenue equation. I've got an equation that relates A to B. How am I going to write equation number 3 that represents the number of seats? What is going to equal 23,000? I heard it. Say it loud. Yeah. A plus B plus C. Right? If I take all the seats in section A and all the seats in section B and all the, not C, where did I get that variable from? A, B, L, hi there. I wanted to say A, B, C so bad. If I take all of those 3 sections and add them together, then I should get all the seats, 23,000 seats. Right? See how we just came up with a system of 3 equations? Okay. And the question is, how many seats are there in each section of the amphitheater? So if I solved this and I got an answer, it would be your x comma y comma z, or in this case, a comma b comma l. Right? If I solve this system, then I should know how many seats are in each section. Okay? So the focus today is just on how to set up a system for a real world problem. And tomorrow I'm going to have you finish it for the work. Okay, so I'm going to have you finish solving that system. Okay? But that's where we're going to stop today. Okay.